One of the first videos that I ever made on this channel was about the difference between relative risk reduction and absolute risk reduction. Well, I've been through nearly 2 years of learning since then, and I think it's time to revisit this topic. Stay tuned. In that earlier video, I used this famous Lipitor ad to illustrate how absolute risk reduction is calculated from a relative risk reduction and a patient's cardiovascular risk. And I granted a simplifying assumption that the relative risk reduction of 36% found in the randomized control trial that this ad was based on would be consistent across all populations. So in that video, I gave this calculation for my supposed 30-year risk and assumed that the relative risk reduction from the ad applied to this situation. But does it really? That's the heart of the matter. First, I'd like to look at an alternative definition of these two terms that I throw out all the time, relative risk reduction, absolute risk reduction. Because while we can give formulas for them, that really doesn't mean as much to us. Relative risk reduction tells us how useful the medication is. How good is it at preventing cardiovascular events? And a lot of times I'll just say heart attacks, but I really mean all cardiovascular events. If we could give the medication to 100 people who would have a heart attack if they weren't treated, then a certain percentage of them would avoid that heart attack, and that is the relative risk reduction for that time frame, and that's another matter. The absolute risk reduction tells us how useful the therapy itself is. Now you may ask, well, what's the difference between the medicine and the therapy? Well, the difference is the medicine doesn't just go to the people who would have a heart attack if they were otherwise untreated, because we don't know who they are for sure. We know in a population there might be a certain number, but we don't know which ones within that population. So the statin is given to a lot more people than just those who are actually going to benefit. That's the difference between the usefulness of the medication and the usefulness of the therapy, the context in which the medication is given. We're meant to believe that the relative risk reduction applies in all situations by way of extrapolations. Certainly what they're trying to imply in the Lipitor ad. Extrapolations are at best questionable and at worst just invalid. And we can extrapolate in various different ways. We can extrapolate over time. We can take relative risk reduction that we see from a 3-year study and we can try applying it to a 10-year study. It's not necessarily valid to do that. We can extrapolate to different risk levels. We can say the relative risk reduction from the Lipitor ad applied to a group who had a 3% risk of a cardiovascular event, and we're applying it to a 20% or a 30% or a 40% risk. That may not be valid. We can extrapolate among different statins and different doses, and obviously different doses, you can see why that's not a valid extrapolation, but even different statins, it's not a valid extrapolation. If we see a randomized control trial that tells us that Crestor or rosuvastatin achieves a certain relative risk reduction, doesn't mean that Lipitor or Mevacor or Livalo is going to achieve the same thing. And then we could extrapolate between populations. A randomized controlled trial on middle-aged American white males may have a far different result than a controlled trial on elderly Korean women. All these are the sorts of extrapolations that we're meant to do in our minds when we read this ad, but none of them should really be done. So let's look. What happens to relative risk reduction as risk increases? Well, in a video a few weeks ago, I put out a chart that showed 10 randomized control trials, and I had normalized it to 10-year studies, which I just told you is invalid, so I didn't do it on this chart. But I've since gathered more data, and you can see here that I have 36 randomized control trials, and this is just the raw data. It's the relative risk reduction that was achieved, no matter what the time frame was, versus the risk that the control group had. And you can see it still seems to decrease. The greater the risk, the less relative risk reduction we get. And I broke it into the 4 groups. If the risk is less than 10%, then the relative risk reduction is 32.5%. Between 10 and 20, the average of these studies, weighted by the size of the studies, is about 12%. Between 20 and 30, it was 16.8%, but there were only 4 trials in that group, and then over 30, it seemed to have dropped way down to 2.2%, but again, only 3 trials, so we have to acknowledge that the data is not real strong when you get over 20%. From the absolute risk point of view. These are the same trials, but instead of relative risk, we're looking at absolute risk. And we can see with one exception that's pretty high there, below 6%, and most of them are below 4%. And you can see that between 0% risk up to 20% risk, it's really less than 2% absolute risk reduction. And then it goes up between 20 and 30, same caveat as before. That's only from 4 randomized control trials, and one of them does seem to be an outlier there. And then over 30, again, we have too few trials to be sure. Just doesn't seem there's a lot of absolute risk reduction there. So we're going to look at 5 of these trials just briefly with some charts that I've developed. The first one we're going to look at is the one that the Lipitor ad was based on, and that's the one circled in red here. We're going to take a graphical look at how well that did. Next, we're going to look at the one with the highest relative risk reduction. That's the one in purple here. And then we'll look at one that's kind of average. I just picked one from the middle. That's the one in brown. The one with the best absolute risk reduction, the one in green, and then finally the one with the highest risk group. So I had developed these charts. The green represents the number of people who are saved from a cardiovascular event by taking the statin in that study. The red is the people who still had the cardiovascular event despite the fact that they were taking the statin. And the yellow is those people who weren't going to have a heart attack anyway, comparing the control group to the treated group. So you can see that the overwhelmingly large part of this population is the people who don't benefit from taking a statin because they weren't going to have an event in the time frame of the study. This particular study was only 3.3 years, so we just have to keep that in mind. The purple study, the one with the highest relative risk reduction, just over 50%. So again, it looks very similar to the other one. The green section here is a little bit bigger than the red. The overwhelming population is that yellow population. The brown is kind of an average, and we see the green's getting a little bigger, but the number of people who weren't helped is even greater than that. This is an important point to keep in mind. The green one, this is the one with the highest absolute risk reduction. It's about 1 out of 12 or 1 out of 11 people who take the statin will end up avoiding a cardiovascular event. And this is where we get into the value judgment. People looking at this may say, yeah, I think that's worth doing, assuming they don't have adverse effects. And I can look at this and say, it's marginal. I'm not sure I'd want to do it. Now, I'd also have to note that this is on a Scandinavian population, so I suppose if you're Scandinavian, you might get this relatively high absolute risk reduction. And then finally, this is a real scary one. The people who are at very high risk, the statin still didn't do much more for them than it did for the people who are at low risk as far as the number of events that were avoided. But the number of people who still had those events was overwhelming here. You're giving them a statin, and there is some small benefit statistically, but the people aren't very much protected at all. And that's something we have to keep in mind here. So how could we improve any of this? Well, we can't improve the relative risk reduction. The medicine does what it does. But we could improve the absolute risk reduction by maybe identifying the people in the yellow and withholding the drug from them. They don't need it. I mean, it'd be nice if we could identify the people who are going to end up with the event anyway, and maybe we could try different things with them and not put all our eggs in the statin basket. Now, it's possible that over time, if these randomized control trials went on a little longer, some of the people would migrate from the yellow into either the green or the red. We just don't know, because as soon as we start thinking that way, we're extrapolating again. But here's a question. How are we ever going to run a study or some kind of trial that's going to help us determine who's in that yellow area and who shouldn't be taking statins? Most statin trials are funded by Big Pharma, by the pharmaceutical companies. And there's only 3 possible results of a study to find a population that isn't going to benefit from statins. Either they're going to fail to find that population, which means the study resources, the study funding was a waste. It may be ambiguous, which means they're going to have to plow more money into it to maybe study it further. And ultimately, what we would want to see is for the study to succeed. Well, if the study succeeds, that's the worst thing for the pharmaceutical company. They have a fiduciary duty to their stockholders. What would happen if we were to identify who isn't going to benefit from statins? They would lose sales. They would lose revenue. It's a lose-lose-lose situation for a pharmaceutical company to investigate in this direction. It would be shooting themselves in the foot, so to speak. We will never see an industry-sponsored study of this sort, so we would have to rely on government-sponsored studies. And of course, then the lobbyists would come out of the woodwork, at least in the United States and Washington. Such a study would never get off the ground. So there are other ways of looking at the data. Unfortunately, to do these assessments, we need access to the raw data, and we're not likely to get that. Independent reviewers aren't going to get access to the raw data because the pharmaceutical companies don't want them poking around and discovering new things in there. So I asked ChatGPT, what are some other ways we could look at this data? And it gave me 6 choices. What I'm going to do is just leave them up for a few seconds each. If you're interested in reading the descriptions, just pause the video and you can read them. The first is survival analysis, which uses specific models to assess the time until events occur. The next is event-free survival, considers performance over time, very similar to the last one, and not just results at the termination of the study. We don't just look at the end and say, well, this many people had heart attacks. Was there some systematic delay in how often people had heart attacks or how quickly they had heart attacks? The number of life years gained is another one. The one study that I looked at in detail seemed to have missed the mark. It was reverse engineered from the available data as it was, but it would have been better if the authors had access to the raw data. They probably would have used a different methodology to analyze the data and probably wouldn't have made the mistake that I believe they did, and you can watch my video on that. Another one, number needed to treat over time, basically a way to properly extrapolate over time, or at least observe the effect of time on the number needed to treat. Competing risk analysis. In these cases, a competing risk may kill someone, so statins could get the credit for avoiding an event when maybe it just postponed it long enough for fate to intervene in another way. Person didn't die of a heart attack that they might otherwise have had, but they died of something else. And then finally, there's cumulative incidence function is another way to extract prevention versus postponement. And again, I need to study these more. A viewer who is trained in epidemiology did make a comment on one of my videos saying that this isn't really the way we would do it, and I accept that. It's probably true, so I need to learn about these ways rather than the chart that I showed earlier. For my closing thoughts, this is a good example of how we have to adjust our thinking in light of evidence. In this case, I used to insist that people who said the absolute risk reduction was only 2% had missed an important point. Well, my attitude turned out to be oversimplified. They turned out to be pretty close, a lot closer than I had previously thought. So to those I maybe lectured about absolute risk reduction, well, I apologize. And I think we've all gained a better understanding with this new look. The sweet spot for statin benefits seems to be in the moderate risk level, what I would describe as probably secondary prevention, but somebody who's not too far gone. It's not 100% certain, but the data that I've gathered so far points towards the higher the risk, the less relative risk reduction to be gained from the use of statins. The most important part of the 3-color pie charts I showed is the relationship of the green to the red. If you're in that moderate risk group and you feel it's worthwhile to take statins, or even if you're in the other risk groups and you decide that it's worthwhile to take the statins, remember the red part of the charts in 35 out of 36 of the randomized control trials, more patients would still have an event than those who were saved from an event. The point is, you're not perfectly protected. It gives you some chance of being protected, but it's less than half. Sometimes it's far less than half. So what does that mean? Well, you should still take other steps, lifestyle, surgery if it's appropriate, whatever it is to reduce risk. And those of you, if you're like me and either you refuse to take statins anymore or refuse to take them ever in the first place, let's not kid ourselves and ignore the risk. We still have cardiovascular risk, and we need to keep learning, measuring, and following a healthy lifestyle to keep the risk at bay. So that's what I have on this topic. If you appreciate this content, please like, share, subscribe, and comment on this or other topics you'd like me to cover. And if you haven't seen this video, I recommend you take a look at it now. Thanks for listening.